Oh, hey there, everybody. So when I have to write on the board to work out problems and stuff, you'll see videos in this format. So this is the 0.3 lesson, which is a review of dimensional analysis, which you learned if you have taken chemistry and you used dimensional analysis to do stoichiometry in chemistry. We obviously won't be doing any stoichiometry in this class because while carbon and nitrogen and oxygen and phosphorus are in it, there's not actually any chemistry problem solving in this class. There is, however, a lot of unit conversions. So when we think of environmental science, a lot of times you think about energy consumption. And so there are problems on the AP test in the FRQs. One of the 4 questions is always a math problem. And the easiest way to get the right answer is to use dimensional analysis. You do not have to specifically use dimensional analysis to answer the questions. However, that is in the scoring guideline, and so you're much more likely to get full credit if you do, because if they can't follow your work and you get the right answer, you'll get 1 out of 4 points. So here's a whole bunch of different metric and English systems. Temperature at 60 degrees is Earth's hottest recorded temperature. At -40 Celsius, it says spit goes clunk, because by the time it hits the ground, it's already frozen. Fun fact about temperature, -40 in Celsius is the same as -40 in Fahrenheit. It's a fun fact. So you can read those. Some of them are real funny. There's a couple not school-appropriate ones, but if you want to follow along in the PowerPoint, you can see those for yourself. Lovely title. There are 3 countries in the world that do not use the metric system, so we are special in America here. The USA uses English system, so does Liberia. Fun fact, Minnesota has a large Liberian population in the northwest suburbs. And Burma is the other one. There was a bill passed in the House of Representatives in the 70s to switch to the metric system, but that never happened because it was very expensive to replace all of the street signs. So I believe it got axed. Do I have to do that, or will it just go? Oh, I wrote on it, so now it's being picky. There we go. All right, so metric system. This is going to give you all of them, but you really only need to know 4 of them. So King Henry died by drinking chocolate milk. That's how you remember them all. King is for kilo. Kilo. Henry is for hecta. Hecta, not a K. I was going to write a K. D is for deca, with an A. Drinking, the other D is for deci. And then C is for centi. And milk is for milli. I misspoke. You have to know 3 of them. The 3 that you need to know are milli, so millimeter, centi, centimeter, and kilo. The ones in the middle here, we don't ever use. If you've been to Europe, or Mexico, I guess, any other country other than the United States, Burma, or Liberia, pop bottles are sold in deciliters. Deciliters, not decaliters. Okay, great. Cool? Super. So if I clear that, I should be able to do that, and it should work. Great. So this is a conversion table. Go ahead and do these on your own. I'll give you the answers, I guess. So 1.123 milligrams to grams. If you want to do this using dimensional analysis, you need to know the equalities. I don't know if you can see me over there. So milligrams to grams. Milli means 1,000th. So there's 1,000 milligrams equal to 1 gram. So if you remember anything about dimensional analysis, these are the 2 things in your fraction. You start with the number in the problem. You change this to be a fraction so that the units cancel. And then when your numerator in that fraction is the final answer, in this case grams, that means you can actually solve it. So you take 1,123 milligrams, this number, multiply it by a fraction. Now you get to use your equality. The same unit that you started with, you always want in the denominator. So since I started with milligrams, down here, I'm going to put milligrams. In the numerator, you want whatever you're converting to, and if it's not the right answer, like the right unit. We want grams. This is grams. So in this case, it is perfect. But if it's not, you want to get closer to the right answer. So then we have our units. Notice I don't have numbers. The units tell me which place to put the right number. Because I have two numbers over here. I got 1,000 and I got 1. Some people, the most common mistake is that you screw up where to put those, whether it's in the numerator or the denominator. So if you pay attention to the units, you shouldn't make that mistake. Over my equality, I have 1,000 by the unit milligrams. So in my fraction, I find the unit milligrams and I put 1,000 next to it. Huh? And then since I have 1 by grams there, I put 1 by grams there. I divide this by that because it's in the denominator. And I get 1.123 grams. Most of you can do some of these in your head, but I recommend you write it out just to be sure, number one. And number two, for practice, using dimensional analysis. Yeah, so there's that one. This one you should have memorized. 100 centimeters is a meter. And then this one's kind of opposite because it's bigger, 1,000 grams. This one, kilogram. I do my lowercase k's like that. So 1.123. Okay, the next one we have 14 kilometers to meters. This one's a nice whole number. Since it's 1,000 to 1, it's just 14,000. Can't see me over there, can you? So 14,000. 1.2 liters to milliliters. Again, it's 1,000 to 1, so you just multiply that by 1,000. 1,200. Please do the dimensional analysis or ask me a question in class someday if you're still confused about this. Grams to kilograms is 0.109 centimeters to millimeters. Well, in this case, look, 1,000 to 100. So millimeters are 1/10 of a centimeter. So since we're going to millimeters, you just multiply that by 10. It's 1,600 millimeters. Kilograms to milligrams, that's going to be a stupidly huge number because there's 1,000 of these in a gram. Sorry, there's 1,000 grams in one of these, and there's 1,000 of these in a gram. So this is a two-step problem, which I'll actually do on the board. That did work. Good. Okay, so for this one, we start with the number in the problem. These two-step ones are tricky, and you might not be able to do them in your head. That's great, because we have dimensional analysis. You don't have to. So I go kilograms. I'm trying to get to milligrams, but here's what I'm supposed to know. And there is no kilograms to milligrams in here. There is, however, kilograms to grams, and then grams to milligrams. So if I put these two things together, it'll work. So I go from kilograms to grams. Look, no numbers. But I'm not in my right unit, so I do need to go one more, change from grams to milligrams. Now I just have to get the units in the right place. So I have 1 by kilogram, 1 by kilogram. In that same equality, I have 1,000 by grams. So in that same equality, I put 1,000 by grams. That 1,000 should not go over there. If they're in the same equality, they need to be in the same fraction. This next one is grams to milligrams. 1 is by grams this time, and 1,000 is by milligrams this time. So whatever 0.2 times 1,000 times 1,000 is, I think it's 200,000. Not positive, but I'm going to write it down because I don't have a calculator handy. It's at my desk, I think. Okay, centimeters to millimeters. 1,000 to 100, that's times 10. So it's just 23. 873 milliliters to liters. It's 1,000 to 1, so you divide it by 1,000, or use dimensional analysis. It's 0.873. And then we have 6 millimeters to meters. Divide it by 1,000. It should be 0.006 meters, if my math is correct. I think it is. So any of these that you can't do in your head, please use dimensional analysis. I think those are all right. Okay, moving on. Oh, look, the answers. Which ones did I screw up? I think I got them all. Good job, Mr. Rasmussen. Look at you go. Okay, so this is a kind of long explanation of how to do dimensional analysis. I don't usually explain it in quite this length. I'm going to link an older YouTube video of mine where I'm about 10 years younger. And I did a good job explaining it that year. So look for that link in your digital packet and watch that one. It's like 10 minutes long, I think, but I did a good job in that video. So it walks you through how to do all this stuff. Hopefully this is mostly review for you, or you have another problem-solving technique that works really well. If not, watch that video that I linked, and or talk to me in class. I'll help you, I promise. Okay, in Europe, gasoline is sold by the liter. Assume that it takes 14 gallons of gasoline to fill the tank of a compact car. How many? That's a lot for a compact car, I think. I think it's usually like 10. Anyway, how many liters of gasoline will it take? And then it tells you the equality here. 1 gallon is 3.7854 liters. In AP Environmental Science FRQs, it will pretty much always tell you all the equalities you need. The things that it won't tell you are the metric prefixes. That's why you need to know those. The kilo, centi, and milli. The bigger ones like mega and giga, it tells you those, so don't be too worried. Okay, so we need to work that problem, I think, and then I go this way and it goes back, right? Okay, great. So it said 14 gallons. So I have 14 gal, dot, line, the dot's multiplication symbol, in case you don't know that. And then I go from gallons to liters, and it said that 1 gallon is 3 point, I don't remember what it was. I guess I could go check, huh? If it's going to let me. There it goes. No, that's the wrong way. I got it. Sorry, kids. I do have a microphone on, so it sounds like I'm exactly where I was. 3.7854. Oops. 3.78. Here I am. 54. Okay, and so I want liters. It's giving me gallons. I don't have a calculator, so that's fun. Let's check in this drawer here. Guess I have a cell phone. That works, right? Oh, no, I don't, because it's recording the video. Good job, Mr. Rasmussen. What's 14 times 4? 56? So somewhere between 50 and 56. You can use your own calculator, right? Great job. Okay, that was fun. I had a great time. Okay, the next one. Some owls maintain territories of up to 3 acres. How many owls could live in a large wooded area of 20 hectares? So I'm not actually going to go to the next slide because I'll just work it on this one. That makes way more sense. These are the type of problems that you'll get on the AP test. This one's a little bit simpler, but you know, as we go through the math problems, we'll do a few in class and you'll figure it out. So we start with the number in the problem. 20 hectares is the number in the problem. And I believe it's abbreviated HA for hectares. A little weird, but there it is. And then it says that hectares are equal to acres. I don't think there's an abbreviation for acre. I might be wrong. But in 1 hectare, it's 2.47 acres. I had a student named Hector once, so it was fun. So 20 times 2.47. Oh, math is fun. What is that? About 50? Approximately, because I don't have a calculator. 50 acres. Very exciting. That's it. There might be practice problems in your digital packet. If there are, do them. If there's not, then I hope this was a good refresher. You'll definitely need to know them before we do our first math FRQ, but probably not immediately. So that's it. Great job.